In this lesson, we will learn about percent proportions. Please open up your packet to page 5. Let's begin at looking at some percents and some proportions that we already know. For example, we know that 80 over 100 is 80% because percent means out of 100. A lot of times when you take tests and quizzes, you might get a grade like 40 out of 50. And this is equivalent to 80 out of 100, or 80%. We know this is the case because we could use a foo, or a factor of 1, and so if we do times 2 to get from 50 to 100, we can also do times 2 to get from 40 to 80. I've written it out as a giant 1 because 2 over 2, or any number over itself, is 1, and we know from the multiplicative identity that we can always multiply by 1 and not change our value. Now let's use this fact that we already know to look at a few different things about percent proportions before I get into the examples. If I told you to find 80% of 50, we know that we should get 40, since we already know that 80% of 50 is 40. And we could set up the proportion 80% of 50 is what number? And when we solve it, we'd get 40. We also could be asked, 40 is what percent of 50? So in this case, we don't know the number that's over 100 because we don't know the percent, but we're saying 40 out of 50 is what percent. Finally, we could be asked 80% of what number is 40? So in this case, we again know that we have 80%, but we're saying that we have the 40 and we don't know the total number. We're going to go through each of these three main types of percent proportions in these notes, but I just wanted to give you an overview. The proportion that we want to use for all of these problems is that we have our part over our whole number is our percent over 100. Sometimes we use the hint that when we're referring to the part, we often see the word is, and when we're referring to the whole, we often see the word of. But we don't want to always rely on a trick like this because it could lead us in the wrong direction. Let's start with number 1. For each of these problems, I'm going to do part A, and I want you to try part B for tomorrow. I'm going to show you how to do them both using a percent proportion, which is our focus, and with a decimal, because some of you may prefer to use decimals. So number 1A says 17% of 64 is what number? Whenever I see my percent, I know that that's the number that goes over 100. So I have 17%, or 17 over 100, of 64. So my whole is 64. And I want to know what number is 17% of it. So I set up my proportion, and I solve it using cross multiplication, or the Band-Aid method. So I have 17 times 64 equals x times 100, or 100x. And then I divide both sides by 100 to isolate my variable, and I get the answer 10.88. It's always important to check to see if this makes sense. 17 is pretty close to a fifth of 100, so I want to know if 10.88 is pretty close to a fifth of 64. And it is. If I had gotten something like 108.8, or even something like 1.088, I would know immediately that I might have typed something in wrong, like maybe I typed in 10 instead of 100, so always ask yourself if your answer makes sense. A different way to do this same problem is to say that to find 17% of 64, I can just multiply 0.17, which is 17%, in decimal form, times 64. This is a faster way to get the same answer, and 17% of 64 is again 10.88. Now let's move to our next section. In number 2, we're finding the percent. This means that we don't know what number will go over 100. Notice it says 26 is what percent of 208. When I see what percent, I know that I'll have x over 100 because I don't know the percent. Now it says 26 is what percent of 208? So I know that 26 is the part of the number that I'm talking about, and it's part of my whole of 208. So I have 26 over 208 equals x over 100, and I want to solve the proportion. When I do this, I get that x equals 12.5. This means that 26 is 12.5% of 208, because I have 12.5 over 100, which is a percent. Now again, we could also use a decimal to solve the same problem. It's not necessarily as straightforward as the other one, however. So it says 26 is, so I have 26 equals, what percent of 208? So what number times 208? When I solve this, I get 0.125, which as a percent is 12.5. In other words, 208 times 0.125 gives me 26, because that's how I would find 12.5% of 208. Again, if the proportions make more sense to you than the decimals, then ignore the decimals. They're sort of like a shortcut, but it's important that you understand why we can just use the proportion of percent over 100 equals our part over our whole. The last type of problem that we have is like problem 3, where we're finding the whole. So it says 3% of what number is 9? So we know that we have 3%, which means that we're going to have 3 over 100. Now it says of what number? So we don't actually know what our whole big number is. We just know that 3% of it, or 3/100ths of it, is 9. And now we have to solve this proportion. And when we do, we get that x equals 300. As always, I should check to make sure that my answer makes sense. And is 3 over 100 equal to 9 over 300? Well, it is, because we know that to get from 3 to 9, we simply do times 3. And so to get from 100 to 300, we also would do times 3. We could check it in other ways too, but this is just one easy way to check it. It's basically making equivalent fractions. Now again, if you prefer your decimal method, we're saying 3% of a number, so 0.03 times some number, is 9 or equals 9. And when we solve this, we also get 300. So in each of the problems, we wanted to set up a proportion. Where it said 17% of 64 is what number, we knew that we had 17 over 100 because that's our percent. And the whole that we're talking about is 64, and we're finding what is 17/100ths, or 17% of it. In the second one, we were told that 26 is what percent of 208, so we have 26 out of 208, and we want to find what out of 100 that's equivalent to. In the third one, we're told that 3% of some number is 9, so our part is our 9, and we don't know the full number that we're talking about, but we know that 9 is only 3% of the number. One thing I want you to be careful of is that the whole is not always going to be bigger than the part. So if we had the following statements, 150% of 20 is what number? That means that I have the whole 20 plus another half of 20, or 30. And the way I would send that up is that I still have 150 over 100, because we know that our percent always goes over 100, and it says of 20. So 20 is our whole, but our part, and I say part kind of loosely, is actually going to be bigger than that. So we have 30 over 20 equals 150 over 100, because we have the full 100% plus another 50%. Similarly, if it said 20 is what percent of 10, we don't know the percent, so we have x over 100, but 20 is what percent, or what part of 10? 20 is 2 whole times 10, so it's 200%, or 200 over 100. And finally, we have 200% of what number is 8. So again, we have 200 over 100. We don't know the whole number, but we know that 8 is our part of our number. And when we solve this proportion, we actually get 4. So 200% of 4 is 8. If this is information overload, then just ignore it. Go back and look at just what I wrote in blue over on the left-hand side, right here. Oops, well, that's okay, the lightsaber. So all of these percent proportions, and try to mimic them in part B for numbers 1, 2, and 3. Tomorrow we'll go over them and we'll do a bunch more practice.